So what we have learned what is a quadrilateral, okay? Then different types of quadrilateral, and among the different type of quadrilateral, we have parallelogram, which has opposite sides parallel, okay? And we are seeing the properties of the parallelogram. What are the different properties of the parallelogram? In properties of a parallelogram, we have seen two theorems. Okay, we have covered till now two theorems. The first one was a diagonal of a parallelogram divides it into two congruent triangles. Okay, so if we are drawing the diagonal, okay, in a parallelogram, then that diagonal is going to divide the parallelogram into two congruent triangles, two same triangles. Okay, now the second theorem that we covered here was in a parallelogram, opposite sides are equal. Okay, in a parallelogram, what opposite sides are equal. Now we will see the converse of this. Okay, in theorem 3, if opposite sides are equal, then it is a parallelogram. See here, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Okay, now let's see how can we prove it. Okay, now what was given that if each pair of opposite sides of a quadrilateral, let's draw a quadrilateral. Okay, so ABCD is what? ABCD is a quadrilateral. Okay, so in which it is what is given that each pair of opposite sides of a quadrilateral is equal. Okay, each pair of means AB is equal to DC and BC is equal to AD. This is given here. Okay, now what we have to do, prove that ABCD, the given figure ABCD quadrilateral is a parallelogram. Now what we have to show to that to prove that the given figure, the given quadrilateral is a parallelogram, what we have to show? The parallelogram qualities. So what is a parallelogram? Which figure is called a parallelogram? In which the opposite sides are parallel to each other. Okay, that particular quadrilateral is called a parallelogram. So we have to prove that AB is parallel to DC and AD is parallel to BC. Now how can we prove that AB is parallel to DC and AD is parallel to BC? If for proving a parallel, two lines are parallel, you should go back in lines and angles. Okay, in lines and angles, if you remember, there were so many rules how to prove that the two lines are parallel. Okay, if two lines are given and a transversal is crossing it and the alternate angles are equal, then the two lines are parallel. Do you remember, Razi and Arham?
Yes, ma'am.
Yeah, so the same thing we are going to apply here. Okay, now how can we say that the alternate angles are equal? Okay, we cannot directly say, no, we have to prove that the alternate angles are equal, so that we can prove that the two AB and DC are parallel or AD and BC are parallel. Okay, so here you can see if I'm joining AC, a small construction I have done, and I have joined here.
Ma'am, your screen is frozen.
Yeah, Aram, because I'm not writing anything. Okay, because I don't know, my pen is not working, so I'm giving some time to chat, just 2-3 more minutes. Till then, I'm explaining from here only. Okay, from this figure only. Okay. So we are going to join AC. Okay.
Ma'am,
So
we just prove that the triangles are congruent, and then we, as CPCT, we will be able to prove that all of
yeah,
them are
alternate angles are equal. Okay. So what do you have to do? Okay, you have to prove that the triangle ABC, okay, triangle ABC is congruent to CDA. Okay, ABC is congruent to CDA. Means the downward triangle, you have to pick it up and flip it, and then you have to keep it above that. Okay, just let me check. I don't know why.
Ma'am, we can use the first theorem.
Just a minute. It is not drawing. Okay, now it is okay. So it is drawing the touch only. Okay, fine. Okay, now your triangle is here. What triangle? Now this is your quadrilateral. Okay, this is not a parallelogram. We have to prove it as a parallelogram. This is a quadrilateral, and what quadrilateral? Just see here. Properly observe it. A, B, C, D. Okay, now we are going to prove that two triangles are congruent. When we have joined AC, AC was not in the quadrilateral. We have joined this AC. This is the small construction that we have done. We have joined this AC. Now we are going to prove the two triangles. Which two triangles are congruent? I'm going to prove triangle ABC. Okay, I'm going to prove triangle ABC and triangle ACDA. Yeah. CDA. Okay. Now ABC. No? Okay. If you see CDA, so you can see here CDA like this. Okay. CDA. Now I want ABC. Okay. So ABC, you have to flip it up. Okay. ABC. Okay. Now understood here? That not here. Sorry. ABC. Okay, so this is the figure. Okay, so you have to just reverse it. Okay, you can mark it here as if we're going to do same. So you can mark here as equal. Okay, so the down figure, the below triangle, what you have to do, you have to pick it up. Okay, and then you have to reverse it. Okay, and then put it over that. Okay, that is a triangle DAC. Okay, have you understood this or not? Any doubt? You just see this particular okay, that A will be A will that point A will be point C. Okay, B D and C A. Okay, ट्राइंगल जिस तरह से आप प्रूव करते हो ना, जिस एंगल को जिस एंगल से आप प्रूव करते हो इक्वल, इन दैट सेम सीक्वेंस यू आर गोइंग टू राइट द बोथ ट्राइंगल्स वैल्यू. ओके, दैट मीन्स ABC is congruent to triangle CDA. Okay, why I'm explaining? Because in the same way we will be proving the angles also. Okay, alternate angles. Okay, so if you see the triangles, I'll just rub it here. Okay, now triangle ABC to triangle CDA. Okay, now in these two triangle, if you see, the AC is common. Yes, AC is equal to AC. Yes or no? This is common side. Now what else? Opposite sides are already given, are equal. Yes, it's given here that AB is equal to DC and BC is equal to AD. So okay, so AB is equal to DC. Okay, and this is given here, and AD is equal to BC. Actually, BC and BC is equal to AD. This is also given. Okay, now all the three sides are equal to all the three other sides. Therefore, triangle ABC is congruent to triangle CDA. Okay, now the alternate angles. What are the alternate angles? This angle, okay. Which two angles you are going to prove? Two alternate angles are there. Okay, that is angle BAC. This one BAC is equal to ACD. Okay, this angle. Okay, and angle BCA is equal to DAC. Okay, so I'm writing here. Okay, that triangle BAC is equal to triangle ACD. Okay, and which other two angles? BAC, no? BAC wala clear. BCA. Okay, or I'm writing BCA is equal to which angle? Angle CAD. Okay, now from what? CPCT. Okay, any doubt here? Anybody? No? Okay, so from CPCT, since the two triangles are congruent, so this angle is equal to this and this angle is equal to this. Okay, but these are what? These are pair of alternate angles. What are these? These are pair of alternate angles. Okay, so therefore, when alternate angles are equal, when AB is parallel to DC and BC is parallel to AD. Okay, for one pair you see. Okay, for this BAC is equal to DCA, AB is parallel to DC, and for the other angle, that is DAC is equal to BCA, AD is parallel to BC. Okay, so both the hence ABCD is a parallelogram. Okay, now let's see the theorem 3. Because theorem 4. Okay, now what does the theorem 4 say? In a parallelogram, opposite angles are equal. Okay, now what we have to prove, that opposite angles are equal in a parallelogram. Okay, opposite angles means angle A is equal to angle C and angle B is equal to angle D. Okay, now since it is a parallelogram, we have to prove that in a parallelogram opposite angles are given. So what is given? That the figure is a parallelogram. Parallelogram means opposite sides will be parallel. That means AB is parallel to CD, AB is parallel to DC, and BC is parallel to AD. This is given. Okay, and what we have to prove, that opposite angles are equal, that means angle A is equal to angle C, angle A is equal to angle C, and angle D is equal to angle B. Okay, so we have to prove this. Understood? Now, how can we prove that? Now, since it is a parallelogram and opposite sides are parallel, that means AB is parallel to CD. Now, if you see here, if AB is parallel to CD, so and AD is a transverse. बस इतना figure आप देखो, okay? AB and CD, and this is the transverse. Okay, this A point, ये जो A point है ना, ये आपका A point है. This is the D point. Okay, this is the transverse. Okay, so if this is a transverse, so then this angle will be equal to this angle. Not this angle is equal to this angle. This angle plus this angle will be equal to 180 degree. Okay, so that means angle A plus angle D will be equal to 180 degree co-interior angle. Yes, consecutive interior angles or co-interior angles, if you remember from lines and angles. Okay, so their sum will be 180 degree. Now, what you are going to do, you see that AD is parallel. AD जो है ना, ये वाला line, this is parallel to this. Okay, and this line, this BC is your transverse. Okay, so this angle and this angle will again be a co-interior angle. So angle D plus angle C will again be equal to 180 degree. Yes or no?
Yes, ma'am.
Okay, same thing you can do on the other side also, or any two. You can do with AB and BC also. Okay, or BC and CD also. Okay, any of the pair you can do. Okay, so if this is also equal to 180, this you can take it as equation 1. This is that 2, and after adding both the equations, what you will get, or you can say that it is 180, 180, both the side 180. So you can say angle A plus angle D is equal to, from angle this first and second, what you will get, both are equal to 180 degree, same quantity, so we can equate them both, and angle D is common on both sides. So what we got, angle A is equal to angle C. Yes or no? Similarly, you can prove it with angle B and D. For B and D, what you can do, you can choose the other side. Okay, you can take B, you can choose this angle and this angle. So angle B plus angle C is equal to 180 degree. Okay, now you can choose this angle and this angle. Yes, so it will be angle C plus angle D. Yes, is equal to 180 degree. Okay, so which implies that angle B plus angle C is equal to angle C plus angle D. Okay, angle C is common, so angle B will be cancelled, and angle B is equal to angle D. Okay, any doubt? So in a parallelogram, what we have seen, that opposite sides are also equal. We have proven in a parallelogram, opposite angles are also equal. Okay, so all these results will help you to prove when we are doing the problems. Okay, Razi and Aram, any doubt in the previous theorem? No. Okay.
No, ma'am.
If in a quadrilateral, each pair of opposite angles are equal. Okay, a quadrilateral, let's make it up. Now this is the just the converse one. Okay, that we have seen. Okay, that if that in a parallelogram opposite angles are equal. Now it is saying the converse means just the opposite. So if in a quadrilateral opposite angles are equal, then it is a parallelogram. Okay, now how can we prove that if opposite angles are equal, then it is a quadrilateral? Let's see. Okay, so ABCD is a quadrilateral. Okay, quadrilateral means, yeah, it's given here that pair of opposite angles are equal. Okay, in this quadrilateral, so that means angle A is equal to angle C and angle B is equal to angle D. Okay, this is given condition here. Okay, this is given condition, given. Okay, now what we have to prove, that it is a parallelogram. ABCD is a parallelogram. Okay, now right now we are having a quadrilateral where angle A is equal to angle C and angle B is equal to angle D. Okay, now if you see here, see angle here. Okay, now it's given here that angle A is equal to angle C. Okay, and angle B is equal to angle D. Okay, now if you are going to add both the equation, okay, if you are going to add both the equation, then what you will get, that angle A plus angle B is equal to angle C plus angle D. Yes, on adding equation first and second. Okay, so angle A, both the side will be these two will be added, and these two will be added here. The angle A plus angle B is equal to angle C plus angle D. Okay, so this you can take it as third equation. Okay, we will be using third equation only here, and okay, but I'm giving you one more condition here, and that will be used for the other part. Okay, for proving the other two sides. Okay, first we are choosing two parallel, proving two sides parallel. Okay, one side means okay, and after that we're choosing the other side, prove that. Okay, so here you can write here angle A plus angle D. Okay, angle B is equal to angle D, so we can write, instead of angle B we can write angle D also equal to angle B plus angle C. Okay, just the reverse. Okay, instead of B I'm writing D, and instead of D I'm writing B. Okay, understood? Now this we will be leaving right now. Okay, and we will be using the other equation, so you can mark it here 4. Okay, now we have to prove that the lines are parallel. Yeah, so we have seen that angle A plus angle B is equal to angle C plus angle D. Okay, but we know that from the angle sum property that angle A plus angle B plus angle C plus angle D is equal to 360 degree. Yes or no? The angle sum property of a the quadrilateral. Okay, so
Yes, ma'am.
what happened?
No, I was showing that, but in the theorem we know that the sum of all the four angles of a quadrilateral is equal to 360.
Yes, the sum of all the angles of a quadrilateral is equal to 360. Okay, so this is the angle sum property says. Okay, now this is equal to 360. Now in this equation, if you are going to keep the value of this angle A plus angle B, okay, or you can say this, instead of angle C and D, we can keep angle A and B. Yes or no? Okay, so angle A plus angle B plus, so you can write here from equation third. Okay, from equation third, it will be angle B plus angle A is equal to 360 degree, because angle C plus angle D is equal to angle A plus angle B. Okay, so what we got? 2 angle A plus angle B is equal to 360 degree. So angle A plus angle B is equal to 180 degree. Yes or no?
Yes, ma'am.
Okay. Similarly, you will get that angle C plus angle D in the same thing. Instead of A and B, you can write angle C and D also. So angle C plus angle D is equal to 180 degree also. Okay. So now angle A plus angle B is equal to 180 degree. So you know that if this is a trans, AB is parallel to BC and AB is a transversal, then angle A plus angle B is equal to 180 degree. Yes, because of co-interior angles. So from this we can prove that AD is parallel to BC. AD is parallel to BC. Okay. Now same from C and D. C and D is equal to 180 degree. C and D is equal to 180 degree. Also you can say same thing. Okay. So either you can take one of the AB or CD. Okay, these two, both these two are going to give you the same condition that AD is parallel to BC. Now similarly, from this one equation that I left here, equation number 4. Okay, in equation number 4, from equation 4. Okay, now what is the equation 4? I'm changing color and I'm writing down angle A plus angle D is equal to angle B plus angle C. C is okay. Okay. Now this is your fourth equation. Okay. Now same we are going to use in the ABCD. Okay. So angle A plus angle B plus angle C plus angle D is equal to 360 degree. Okay. So instead of angle A and angle D, we are reading B and C. So it will be 2 angle B plus angle C is equal to 360 degree. So that means angle B plus angle C will be equal to 180 degree. Okay. So angle B plus C. So this tells that this tells that AB is parallel to DC. Okay. From this we conclude, therefore, AB is parallel to DC, you can say. CD also. DC. Understood this? Or any doubt is there? Razi has left, I think, some net issue here. Are have any doubt? Understood how we prove? We have used co-interior angles. Okay. Now, what happened? Razi is left. It was facing net issue or what? Any doubt in any of the theorems around? Your another student didn't came, Amulya.
But the first few classes were the trial. She's now only doing CMP.
Okay, we'll just wait. Maybe Razi may join because otherwise it will be left. Okay. So till then, you think how you are going to prove that if the diagonals of a parallelogram bisect each other? That how can you prove that diagonals of a parallelogram bisect each other? Bisect means your all this.
And they will like meet at one point.
Yeah. So bisecting means AO is equal to OC and OB is equal to OC. So it will be divided into equal parts. Yes. So how can we prove that? We can take two triangles and prove them congruent. Yes. In triangle C, in this triangle AOD, and one triangle I'm taking this one. Okay. In these two triangles, it is a parallelogram. So sides are AD is parallel to BC. Since AD is parallel to BC, so you can prove that the part of angle A is equal to part of angle C. That means DAO is equal to, okay, but all three angles we are not going to choose now. So what you can do that, yeah, both the angles you can take, okay. So this angle is equal to this, and this particular angle ADO is equal to OBC, okay. Alternate angles because the lines are parallel and it transverse is going through it, okay. Now, and AD is equal to BC. Why? Because it is a parallelogram, and in parallelogram, opposite sides are equal, okay. So I have written also here opposite sides of a parallelogram ABCD are equal, okay. So AD is equal to BC. Understood? So we are having what? Angle, side, angle, ASA. Yes, two angles are there, and the side between the two angles is we have taken, okay, ASA. So from ASA, we have proved that the triangle AOD is congruent to triangle BOC. No, sorry, AOD is congruent to triangle COB. Okay. Now, if we have proven that the two triangles are congruent, so from CPCT, we can say that AO is equal to OC and OD is equal to OB. Yes, this is equal to this and this is equal to this. Yes, any doubt around? Okay. So the diagonals of a parallelogram bisect each other. Okay. Since Razi is also left and no one of is there of class 9. Okay. So we'll stop here only. Okay. Any doubt? Whatever in any of the theorem from theorem 1 to theorem number 6. Any doubt?
No, ma'am.
Okay. So we'll stop here only and bye-bye.